Hi, welcome. Let's take some practice questions under calculus of multivariable functions and see how to solve them. Question 1 says, given the following function, z equals 8x squared plus 14xy plus 5y squared. Write down there. So to solve this, the first question says we should write down the first order partial derivative with respect to x. So to do that, first, we recall the function, which is z equals 8x squared plus 14xy plus 5y squared. So to solve A, it says find the first order partial derivative with respect to x. So this means we should differentiate z, that's z, with respect to x. So anywhere we see y should be considered as a constant. That's the meaning. So to differentiate z with respect to x, we are going to write it as partial z over partial x. We won't write it dz over dx. No, we are not looking at total derivative. We are looking at partial. So this is a symbol we use, partial. It's called partial. Okay. So partial z, partial x should be equal to. So we take the first function. The exponent of x here is 2. Okay. We multiply the whole thing by 2 and subtract 1 from the exponent. So let's do that. So that will give us 2 multiplying 8x exponent 2. Then we subtract 1. Plus, now when we come to the second one, here we have x and y in it, okay, but we are differentiating with respect to x. So for that matter, y should be considered as a coefficient of x, just as 14 is a coefficient of x. So y is a constant. Okay. So what is the exponent of x here? It is 1. So we multiply the whole thing by the exponent of x, which is 1, and subtract 1 from the exponent. So that is 1 multiplying 14x exponent 1 minus 1 y plus there's nothing x in the last one. Remember, we are differentiating z with respect to x. So since there is no x in this, then differentiating this with respect to x should be 0 because y is a constant in this case and 5 is also a constant. They are both constants. Since there is no x there, so it must be 0. So let's simplify this. So partial z partial x should give us 2 minus 1 is 1, isn't it? And then 2 times 8 is 16. So that will give you 16x exponent 1, which is what? 16x. Okay. Plus, now 1 minus 1 is what? 0, isn't it? So 1 minus 1 will give you 0, and x exponent 0 should give you 1. So it means so within the bracket, you have 14 times 1 times y, and that will give you 14y. Multiplying the 1 outside, it remains 14y. Okay, so plus 0. We don't need to write the 0 anymore. So partial z, or when we differentiate z with respect to x, we get 16x plus 14y. So let's look at question B. B says we should write down the first order partial derivative with respect to y in this case. So we are taking this same function and differentiating it with respect to y now. So we're going to write this as partial z partial y is equal to. Now when we take the first one, 8x squared, there is nothing y in it. Remember, we are differentiating with respect to y. And there is no y here. So since there is no y, the whole thing is considered as a constant. So when we differentiate this whole constant with respect to y, it should give us 0. Okay, so it will be 0. Plus, then let's differentiate this second one with respect to y also. Now y has an exponent of 1 here. We multiply the whole thing by the exponent of y, which is 1, and subtract 1 from the exponent. So that should give us 1 multiplying 14x y exponent 1 minus 1. Okay, then plus, now there is y here also. So we multiply the whole thing by the exponent of y, which is 2, and subtract 1 from the exponent. So let's do that. So that will give us 2 multiplying 5y exponent 2 minus 1. partial z partial y will be equal to the 0. We don't need to write it anymore. Okay, so let's simplify this. So 1 minus 1 is 0, isn't it? And y exponent 0 should give you 1. So this means 14 times x times 1, and that will give you 14x. Multiply by the 1 outside the bracket, it remains 14x. So this is 14x plus, so let's simplify this also. 2 minus 1 is 1, isn't it? So you have y exponent 1. So 2 times 5 is 10. So that gives you 10y exponent 1, which is the same as 10y. So when you differentiate z with respect to y, you get 14x plus 10y. Question C says, we should write down a cross-order partial derivative. To write down cross-order partial derivative, it means you should differentiate the partial derivative of z with respect to x with respect to the second variable, which is y. Or you should differentiate the answer you got for partial z partial y with respect to x, which is its second variable. You get the same answer, either of them. Okay, so I want to use the first one. So I'm recalling partial z with respect to x, which is 16x plus 14y. Now, I want to differentiate partial z partial x with respect to y, with respect to the second variable. You see that? So that will give you the cross-order partial derivative. If you differentiate partial z partial y with respect to x also, you get the same answer as the one I will get here. But I decide to use this. Okay. So let's differentiate this with respect to y now. So to differentiate it with respect to y, we will now write it as partial square z over partial xy. Okay. Now we are differentiating with respect to y, and there is no y in this first one. So the whole thing is a constant. So when we differentiate this whole thing with respect to y, and since there's no y there, it will become 0. Plus, let's differentiate this with respect to y also. Y has an exponent of 1 here. When we multiply the whole thing by 1, we also subtract 1 from the exponent. So we have 1 multiplying 14y exponent 1 minus 1. So let's simplify. So partial square z partial xy will be equal to, there's no need writing the 0 anymore. So 1 minus 1 will give you what? 0, isn't it? And y exponent 0 is 1. So it means within the bracket, we should have 14 times 1, which is 14. Then we multiply by what is outside the bracket, which is 1. So that gives us 14. It remains 14. So the cross-order partial derivative is 14. If you should take this one also and you differentiate with respect to x, you get the same 14. You must get the same answer. So that is the final answer to this. So let's proceed to question 2. Question 2. Given the function z equals x exponent 0.3 multiplying y exponent 0.7, write down the cross-order partial derivative. So to solve this, first let's recall the function, which is z equals x exponent 0.3 multiplying y exponent 0.7. Now the question asks us to find only the cross-order partial derivative. But you can't easily get a cross-order partial derivative without knowing the first-order partial derivative of either x or y, either of them. So for that matter, you need to find partial z, partial x, or partial z, partial y before you can find a cross-order. So I have decided to find partial z, partial x. Okay, so for the first-order partial derivative with respect to x, you can choose to find yours with respect to y. Our cross-order answer will be the same. Differentiating z with respect to x. So partial z, partial x will be equal to. Now, since I'm differentiating with respect to x, y is going to be considered as a coefficient, a mere coefficient of x. Okay. So we multiply the whole thing by the exponent of x and subtract 1 from the exponent. So what is the exponent of x? 0.3. So it is 0.3 multiplying the entire function, then we subtract 1 from the exponent of x. Okay, so let's simplify further. So partial z partial x will be equal to, Now 0.3 minus 1 should give you negative 0.7. So that will give us 0.3 multiplying x exponent negative 0.7 multiplying y exponent positive 0.7. So this is the answer to partial z partial x. So from here, we can now find a cross-order partial derivative. So for the cross-order partial derivative, we are going to differentiate partial z partial x now with respect to y. Okay, so when we are differentiating it with respect to y, we are now writing it as partial square z over partial xy. Okay, now since we are now differentiating this particular one with respect to y, then we take the exponent of y and multiply it by the whole thing and subtract 1 from the exponent of y. So to do that, we take 0.7, which is the exponent of y, and multiply it by the whole function and subtract 1 from the exponent of y. So that's 0.7 minus 1. Okay. So to simplify it further, that will give us, now 0.7 times 0.3 is what? That's 0.21, isn't it? Multiplying x exponent negative 0.7. Then 0.7 minus 1 is negative 0.3, isn't it? So multiplying y exponent negative 0.3. So the cross order partial derivative for this particular function is 0.21 x exponent negative 0.7 multiplying y exponent negative 0.3. So that's the final answer to this. So let's take question 3. Question 3. Write down the first order partial derivative with respect to y of the following functions. So we have from A to C. So let's see how to solve them. For question A, let's recall the function, which is z equals 4x exponent 3 plus 2x exponent 2y minus 7y exponent 5. Now, the question says we should differentiate with respect to y, only y. So it means we should find partial z, partial y. Okay. So, to find partial z, partial y, we are only differentiating with respect to y. So anywhere we see x, x should be considered as a constant wherever it is alone. And when it is with y, it should be considered as a coefficient of y. Okay. So, since there is no y in the first one here, then when we differentiate this with respect to y, it should be 0. Plus, now there is y here, but the exponent of y in this case is 1, isn't it? So, we multiply the whole thing by 1 and subtract 1 from the exponent of y. So that will be 1 multiplying 2x exponent 2 multiplying y exponent 1 minus 1. Then minus, here too there is y. So we multiply the whole thing by 5, which is the exponent of y, and subtract 1 from the exponent. So that should be 5 multiplying 7y exponent 5 minus 1. Okay. So let's simplify this further. So partial z partial x will be equal to, there is no need writing the 0. So in the bracket, we have exponent of 1 minus 1, which will give you 0. And y exponent 0 will give you 1. So within the bracket, we should have 2 multiplying x squared multiplying 1. And that will give you 2x squared only. So multiply 2x squared by what is outside the bracket, which is 1. That remains what? 2x squared. Okay. Minus, now 5 minus 1 is what? 4, isn't it? And 5 times 7 is 35. So that will be 35y exponent 4. Question A, we get 2x squared minus 35y exponent 4. So that's the answer to question A. So let's look at question B. Z equals, in one bracket, 2x exponent 2 plus 6y, all multiplying 5x minus 3y exponent 3. Now, there are two ways you can solve this. One, it's either you simplify this bracket and you solve directly like the previous question, or Whenever you have two brackets multiplying, to differentiate, you are going to use the product rule. Okay. To find partial z, partial y, remember, I said we are going to use the what? The product rule, which says u times v prime plus v times u prime, where u is the first one and v is the second function. Okay. Now, when we say v prime means differentiate v with respect to that variable you are looking at that moment. Okay. And when we say u prime also means differentiate u with respect to the particular variable in question. Now, we are finding partial z, partial y. Okay. So, to get partial z, partial y, let's recall our u. What's the u? U is 2x squared plus 6y. So we write it. Multiplying v prime. Now, what will be v prime? V prime means we should differentiate v with respect to y, since we are finding partial z, partial y. So we should differentiate v with respect to y. Now, when we are differentiating z with respect to y, within the bracket, okay, the whole thing in this bracket is v, and we are differentiating it with respect to y. Now, for the first term in the bracket, there is no y. So the first term will be 0. Then in the second term, there is a y. So we multiply this 3, which is the exponent of y, by the whole thing, and then subtract 1 from the exponent. So that will make it 0, which is this, minus. When we multiply this 3 by the whole thing, we have 3 multiplying 3y exponent 3, then we subtract 1. Okay. Then plus this addition here. So we also recall v. So what is v? V is 5x minus 3y exponent 3. And multiply it by u prime. U prime means we should differentiate u also with respect to y. So to differentiate u with respect to y, since the whole thing here is u, the first term doesn't contain y, so it will be 0. But the second term has a y, and y is exponent 1. When we multiply the whole thing by 1 and subtract 1 from the exponent, we write it as 0 plus, within the bracket, 1 multiplying 6y exponent 1 minus 1. Okay, so let's simplify this further. So partial z, partial y will be equal to 2x exponent 2 plus 6y multiplying. Now, 3 minus 1 is what? Is 2, right? And then 3 times 3 is 9. So you have negative 9y exponent 2. So multiplying negative 9y exponent 2 plus. Now here too, we can write it down, 5x minus 3y cubed multiplying. Now 1 minus 1 is 0 and y exponent 0 is 1. So 1 times 6 is 6 times the 1 here is 6. So the whole thing in this bracket will be 6. So multiplying 6. So we simplify this also further. So partial z, partial y will be equal to. Now to simplify this further, we are going to multiply these two brackets, then multiply these also, and add everything together, if possible. Now negative 9y exponent 2 times 2x squared will give you what? So to multiply them, 2 times negative 9 is negative 18, isn't it? Multiplying x squared, y squared. So that will be negative 18 x squared, y squared. Then next, 6y, positive 6y, okay, times minus 9y squared should give you what? You multiply 9 by 6. 9 times 3 is what? 27. 27 by 2 is 54. So it means 9 times 6 is what? 54. So that will be minus 54 y exponent 3, because you are multiplying y exponent 1 and y exponent 2. You add the exponents, that will be y exponent 3. So this place will give you minus 54 y exponent 3. Okay. Then positive 5x times 6 should give you, or 6 times positive 5x should give you what? Positive 30x. Okay. And then here we have negative 3y cubed multiplying 6. Now, 6 times 3 is what? 18. Or 6 times negative 3 is negative 18. Y exponent 3. So that will be negative 18y exponent 3. So when you look at this, we have y cube here, and then we have y cube here, meaning we can simplify them. So partial z partial y will be equal to minus 18 x square y square. Then when we take minus 54 y cube minus 18 y cube, since they are like, we can subtract them easily. Okay, so when we take minus 54 y cube minus 18 y cube, it should give us what? Minus 72 y cube. Okay, then plus 30x. So that's the final answer to this. So let's look at question C. C. Z equals x squared plus 2y all exponent 4. To differentiate z with respect to y, in this case, where you have the whole thing in the bracket having one single exponent, okay, we are going to use the chain rule. So in this case, to get partial z partial y, we can say partial z partial u times partial u partial y. Now what do I mean by this? Now what we are going to do is that we let what is in the bracket be equal to u. So u equals x squared plus 2y. The only this, the one in the bracket. Okay. So if the entire thing in the bracket is u, then we can rewrite z as z equals u exponent 4. Because we've let the whole thing in the bracket be u. So z will be equal to u exponent 4. So from these two, we can now find partial z, partial y. So partial z, partial y will be equal to. So let's find partial z, partial u first. Now we should differentiate z with respect to u. And to differentiate z with respect to u, we use the exponent of u, which is 4, to multiply the u exponent 4 and subtract 1 from the exponent. So that will be 4 multiplying u exponent 4 minus 1. Okay. Then times, so we bring the multiplication. Then we also find partial u, partial y. It means we should differentiate u with respect to y. So in this case, when we differentiate u with respect to y, this will be 0 because there's nothing y there. And this part, you have y exponent 1. We multiply the whole thing by 1 and subtract 1 from the exponent. So we say 0 plus 1 multiplying 2y exponent 1 minus 1. So let's simplify further. So 4 minus 1 is 3, isn't it? So if 4 minus 1 is 3, then you have 4u exponent 3. Multiplying, now this place also, you have 1 minus 1, which is 0. So you have y exponent 0. And y exponent 0 is 1. So 1 times 2 is 2, plus 0 is 2. So you have 2 here. 4u exponent 3 times 2 should give you what? It should give you 8u exponent 3, isn't it? So the final answer is 8u exponent 3. But you can't leave your answer this way because you let u be equal to something. So we have to replace that back over there. So partial z partial y should be equal to 8. So we are going to replace the whole u with x squared plus 2y. We bring it back there. So we have 8 multiplying x squared plus 2y all exponent 3. The exponent of 3 is only affecting the entire thing in the bracket. Okay. So the final answer to C is 8 multiplying x squared plus 2y all exponent 3. So that's the final answer to this. So I'll end it here for now. In the next video, we look at total derivative. Thank you.